I just came across this incredible collection of prefix sum algorithms on GitHub. They're implemented in CUDA, D3, D12, Unity, and WGPU.
Wait, really? That sounds useful. So, are these algorithms theoretically portable to any wave, warp, or subgroup sizes?
Exactly, it's like the holy grail for GPU programming, but I'm curious, how does that work in practice?
Well, the idea behind prefix sums is pretty neat. It allows for efficient aggregation of data across parallel processes.
Right, it's like when you want to quickly add up values in a giant array. But do they really scale well across different architectures?
That's a good question. Theoretically, yeah, but performance can vary widely based on the hardware specifics.
So there's a chance that what works like a charm on one GPU might flop on another.
Exactly. And let's not forget that the data layout can also impact efficiency. We might be oversimplifying here.
Right, if one GPU is optimized for a specific data structure and another isn't, that could be a huge issue.
Totally. It's like how a certain recipe might turn out amazing for one chef but not so great for another, depending on their tools.
Haha, yes, and I also find it wild how these algorithms are cross-platform. What's the trade-off there?
Well, portability often compromises some performance optimizations unique to specific architectures. It's a balancing act.
Ah, that makes sense. So developers have to decide between speed and flexibility. That's a tough choice.
Exactly. And given the rise of different GPU architectures, that choice is more critical than ever.
What about the user experience? I mean, if you have to rewrite or tweak the code for different setups, that's cumbersome.
Absolutely, and that's a real hurdle. The developers might end up spending more time optimizing for performance.
So while this collection is a valuable resource, it isn't a magic bullet for every situation.
Spot on. It's more like a toolkit. You still need to know when and how to use the right tool for the job.
Speaking of tools, do you think these algorithms open up new possibilities in game development?
I would say so. Faster computations can enhance overall game performance and player experience.
But does that mean every game would benefit equally? I imagine some might not need such intense optimization.
That's true. Smaller games or those with less intensive graphics might not see much change.
Interesting, so it's like not every car needs a turbocharger, right?
Exactly. And not every game demands the same performance level. Tailoring to user needs is crucial.
What about the learning curve for developers using this collection? Seems like it could be quite steep.
Yeah, the nuances of each implementation could overwhelm some, but it's also a great learning opportunity.
True, but potential roadblocks might hold them back. I wonder how accessible the documentation is.
Good point. Well-structured documentation could be a game changer, making adoption smoother.
So a mix of good documentation and community support might make or break its success.
Absolutely. A robust community can also provide valuable insights and troubleshooting.
This feels like a fascinating intersection of technology and creativity. Such potential.
Definitely. But it also raises questions about the sustainability of continually pushing performance boundaries.
Sustainability, you say? That could lead to a whole new dialogue about energy efficiency in computing.
Exactly. Efficient algorithms become even more critical as we consider environmental impact.
And it makes me wonder how developers balance innovation and sustainability going forward.
That's a pressing question. The tech world needs to think about its footprint, especially with scaling.
So what's the bottom line? Is this collection a promising step in the right direction?
I'd say yes, but the challenges are real. Harnessing this potential will require careful thought and consideration.
Right, so while it holds promise, there's a lot to navigate in ensuring it's beneficial.
Yeah, and that's kind of the beauty of tech. It evolves as we do, leading to exciting discoveries along the way.
Absolutely, but it leaves me thinking about how we can drive innovation while still being mindful of our impact.